Okay, so now that we have our circuit, the first LDR, the first light sensor plugged in, I'm going to write the code, take you through the steps of writing the code so that you can read this sensor. And then we're going to look at the output and how to interpret it and how we can work with it. All right, so without further delay, I'll just get started. So over here on the left hand side we have the basic sketch. By now you're probably already familiar. Setup runs 1, loop runs all the time, runs while the board is powered. And the first thing I need to do is again open up serial communication to my computer so that I can the little board can talk back to me. So to my computer, sorry. It's weird to talk and write code at the same time because you always rumble a little bit, and in any case I seem to be rumble quite a lot in these videos. It's super odd to talk to a webcam when you know that you can imagine the faces of the people that you are actually talking to, because I know my students but I haven't seen them in quite a while, and I'm really looking forward to see you in person. Over here, the pin mode specifies, so these first two lines that I just did, what they do is just establish communication back with my computer from the little board, and then we're going to tell the board, okay, I want this pin or this leg of the microcontroller to be an input, and for that I specify which leg I want, so which pin A2, and this is going to be an input. But you know, we're going to be using A2 quite a lot, so sometimes it happens that you want to change your circuit layout and you want to change the pin, and then you change a wire, and then you have to come to the code and you have to replace this as many times as you see it in the code. So I like to make a variable up here called int pin sensor, and then say that this pin is going to be A2, and then use a variable instead. So I can call this pin sensor. Again, you saw me do this in P5.js as well, so it's a good practice to always put magical numbers or constant numbers, give them a name, and then use them. And then the instruction, I'm also going to put another variable here called val for value, and I'm going to set it to 0 to start with. And this is where we are going to save the sensor reading. So the sensor reading in my case comes from an analog read. So when we have in Arduino based boards and the HUSA and basically in the Arduino environment, when we want to read a light sensor sensors provide analog outputs. So the output of the sensor is our input here in this case, so we want to read something analog. It's an analog value, and this value is going to come from A2. But because I named the sensor for my pin right here, I can use the name instead of the pin there, and then so we have it here in two places. So if I rewire my circuit and what was in A2 now becomes A4, I just have to change it here in one place. So that's one of the advantages of naming your things, so that you only have one place to change them later, so there's less room for error. Now we have the reading of our sensor in the variable val, and in my case all I want to do right now is just print it, serial print, and then I'm going to print the actual value out, and then you know what, I'm actually going to I'll do that, and then it will be extended later when you add more sensors. And then this print line, this is a little different from the instruction above. This ends in ln. What that means is that it's going to print, it's like pressing enter. So on the output, it's going to print a new character, a carriage return character as it's called, so that every value gets printed on its own line. You will see what that means in a moment. And then right at the end of this loop, I'm going to add a delay. Now, while the Arduino is powered, it runs the loop, and it runs it as fast as it can. but that's not always what we want from a sensor. We want to data rate limit the sensor. So let's say that we are trying to catch a phenomenon such as a sunset. A sunset takes maybe like 15 to 30 minutes, to take place. So we don't want to capture a sensor reading every millisecond. You can take a sensor reading every second, and that should be just about enough to detect the cadence of light in a sunset. So what we do is limit this rate, and this is equivalent to saying, so 1 second has 1000 milliseconds. If I divide this by 20 millisecond pause, which is what the delay does, this will give you approximately 50 readings. Is that 50? Yeah, 50 readings a second, which is what we are after, a maximum of. So we know that this sensor is in particular going to give us 50 readings a second. If we want 5 readings a second, we will change that for 200. So 200 times 5 is 1000, and but we go for 50 readings a second, which is plenty good for our project. In fact, we can go higher. Okay, and we are pretty much ready. So right now, Arduino, before it builds the project, it wants us to save it. So I'll save it. I'm going to call these IoT Sense Light, for example. That's it. And let me check again. Yeah, everything looks good. That's it. That's all it takes to read the little light sensor here. Let's see if that's the case. First, I verify the program. I compile the sketch. Takes a few seconds. Tick tock, tick tock, tick tock, tick tock. And then I upload to the board. When I do this, you will see the front of the board hopefully flicker a little bit. So there should be an LED there somewhere visible where it flickers. I don't think it's visible on the camera. Well, trust me, it's uploading. Otherwise, you already see an error. You get all this strange output, but if it was successful, it will say here, done uploading, and that's it. Now, if this was successful, let me reveal this in the stream as well. Yeah. So if this was successful, we should now be getting some serial output. Serial is what this board, transmits through the USB cable back to my computer. So you can verify that by using the serial monitor or the serial plotter. I'll show you both so that you can see. So the serial monitor, what it does, yeah, there we go. You see, it's printing all these crazy fast numbers. I can stop the auto scrolling here if I want to pay attention to the numbers. So there are numbers around 830 something, blah, 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 blah. And if I now block the light from the sensor, you see those numbers change. Now that's not very intuitive, is it? Like just looking at some numbers are, I mean, programmers can deal with cataclysmic levels of text, but we don't really care. We are visual people, so I prefer the serial plotter. And that is basically giving us the same readings. When you start, so this is basically doing the same thing as the serial, but it's plotting them as a graph. And as you can see, the signal is quite noisy. It's trying to auto scale. But you see, there we go. That's my interaction. So the moment I block the light a little bit, and as you can see, I don't have to be very far away. Like just my fingers approaching will change the light level. So this is quite a sensitive sensor. Now it's not only your hand. Of course, I made this little thing out of Chinese food. Jesus, my words are missing. I've been alone in this room for way too long. So you can also play interactions with other things. You can use a mirror to direct light to it, and use a mirror to interact with your little circuit. You can hide this sensor inside of a cardboard box that has a little window in it, and when you open the window, the sensor will automatically detect the change in light levels, etc. Now, as you can see, the signal has a bunch of spikes here and there. It's quite noisy. This is electrical noise. There are ways of going about that. I'll fix it in the code. But I don't need to do that in this video. I will provide you with a sketch that already has a smoothing for the readings. But this is the basics of how to read one light sensor and how this light sensor basically picks up interactions with it. Yeah, I think that's it for this video. Thanks for watching, and I'll see you in the next one.